Today we're going to look at some problems where we have to use trig substitution to take the antiderivative of an integral. So with trig substitution we're going to see one of three things: square root of a squared minus x squared, square root of a squared plus x squared, or square root of x squared minus a squared, somewhere in the integral. And right here is kind of a key. If you have square root of a squared minus x squared, we're going to use the substitution x equals a times sine of theta. For square root of a squared plus x squared, x equals a times tangent of theta, and square root of x squared minus a squared, then x equals a times secant of theta. So we have some steps here to follow to do these problems. First is to figure out which one of these three that we're dealing with, and to figure out what a is. So in our first example, number 1, we have 16 minus x squared under the square root. So that would be our first option up here. So a squared in this case would be 16, so a is 4. And since we're dealing with this scenario, x is going to equal a, in this case 4, times sine of theta. So we're going to use that to substitute in to our equation. And then dx, derivative of that, is going to be 4 times cosine of theta d theta. So basically we're substituting in. That second step is to substitute for x and dx. So wherever we see just a plain old x, we're putting in 4 sine of theta. Wherever we see a dx, we're putting this in. So we end up with the antiderivative of 1 over 4 sine of theta squared times square root of 16 minus 4 sine of theta squared times, in place of dx, we're going to put 4 cosine of theta d theta. So now we need to go ahead and do a little simplifying. We can bring that 4 cosine of theta up to the top. Down here we have 16 sine squared of theta. Inside the square root we have 16 minus 16 sine squared of theta, and then our d theta at the end. So now we're trying to do step 3, evaluate the integral in terms of theta. So more simplifying needs to take place. We can take the square root here and factor a 16 out of each of these. We can also simplify the 4 over the 16 here, so we end up with just cosine of theta on top, 4 sine squared of theta on the bottom. And like I said, factor that 16 out. And when we factor that 16 out, we get 1 minus sine squared of theta, which is a Pythagorean identity that we should know. And that should be helpful for us to simplify things. So we get 16, and 1 minus sine squared of theta is just cosine squared of theta. So we can simplify that square root. Square root of 16 is just going to be 4. Square root of cosine squared is just cosine of theta. So those cosines, top and bottom, cancel out. And we're left with 1 over 16 times sine squared of theta, d theta. Well, that 1/16th, I'm just going to pull that out in front. That's a constant. We can pull that out in front of the integral. 1 over sine squared is just cosecant squared of theta. And we know the antiderivative of cosecant squared is negative cotangent. So we end up with 1/16 times negative cotangent, so I'm going to put the negative in front, plus c. So you think we're done now, but remember we started off this problem in terms of x. We did some substitution and we put it in terms of theta, but we want our final answer to be in terms of x. So the fourth step in this process is to write your answer in terms of x. And we can do that by using a drawing to help us. So if we take this information right here, x equals 4 sine of theta. Well, if x equals 4 sine of theta, that means sine of theta equals x over 4. Well, with that trig function, we can draw a picture of a right triangle. Here's our theta. The sine is x over 4, so that means the opposite side is x. Hypotenuse is 4. To figure out this missing side, we could use Pythagorean's theorem. Now, I'm going to only use Pythagorean's theorem once, because you're going to see a little trick after this. Let's say this is side B right here, this side. Well, then x squared plus b squared equals 4 squared. And we want to solve for b. So b squared is going to be equal to, we'll just change this to 16 minus x squared. And we need to take the square root of that. So b is the square root of 16 minus x squared. Does that look familiar at all? It should. It's what we started off with in that square root, and that's why this trig substitution works. So this side right here, that missing side is always going to be that square root that we start off with. So you don't have to use Pythagorean's theorem to figure it out. It should be the same each time, whatever we started with in the original problem. So now this triangle, we're going to use this to put our final answer in terms of x. So our answer over here was negative 1/16 cotangent of theta plus c. Well, we need to replace cotangent of theta. So we look at this drawing. Here's theta. Cotangent is a reciprocal of tangent. Remember, tangent is opposite over adjacent. So cotangent is adjacent over opposite. So that's going to be square root of 16 minus x squared over x. So that's what cotangent is. We're just going to replace this cotangent with that. So we get negative 1/16 times that whole thing. So I'm just going to write it like this. We get negative square root of 16 minus x squared over 16x plus c. I just multiplied negative 1/16 times this, put the 16 on the bottom here, and just combine it into 1.